Hi guys, welcome to Safi Mixed. In this video, I'll talk about the power rule of derivative. That is, how do we find the derivative of function when the function is written as a power of the independent variable. For example, if we have a function of the form f of x equals x power n, how do we find the derivative of this function? So I would like to create a rule, a formula, by using the definition of the function. And we know from the definition of the function that the derivative of the function from the basic definition equals limit h tends to 0 f of x plus h minus f of x divided by h. So I want to use this definition of the derivative to find a rule for finding the derivatives of the power of the variable x. So if I use the values in this definition, then I can write that this is in fact equal to limit h tends to 0, that f of x plus h is in fact x plus h raised to the power n minus x raised to the power n divided by h. And so we first need to find an expansion to this term, and that is quite easy because we know from binomial theorem we can expand this in binomial theorem, and from binomial theorem we know that x plus h can be expressed in the form x power n plus n x power n minus 1 h plus n into n minus 1 divided by 2 x power n minus 2 into h squared and so on, plus so on. At the end we have n x h power n minus 1 plus h power n. This is the expansion of this term through binomial theorem, and if I substitute this value at this position, we get limit h tends to 0. This whole term, I write this x power n plus n x n minus 1 h plus n into n minus 1 divided by 2 x stands for minus 2 h squared and so on, n x h n minus 1 plus h n. This is the value of this term. Then I write minus x to the power n and the whole divided with h. Now if I remove the brackets, I can write it like this in the next step, and then you see I can cancel this first term with this last term, and I want to break this whole term into two separate terms, one for this one and the other for that. So I can write this as limit h tends to 0 n x power n minus 1 h divided by h, and then plus n into n minus 1 divided by 2 x power n minus 2 h squared plus nx h n minus 1 plus h power n, the whole of this divided with h. Now I can cancel this h with this h. With this cancellation, this term becomes independent of h. So I take this term to the left of the limit, and the limit now applies only to this term. And that means I can rewrite the equation in the form nx n minus 1 plus limit h tends to 0 into n. And one thing more, I can take, since now every term inside this series has an h with it, therefore I can take that h common from all of them and can rewrite this as n into n minus 1 divided by 2 x power n minus 2, and that should become, instead of h square I would have an h over here, and the next term instead of hq I would have h square, and so on. With that I can write this plus nx h, and this one, since I'm taking h common, therefore it will become n minus 2 plus h n minus 1, the whole divided with h. I can cancel this h with this thing, and now what do we have? If I apply the limit h tends to 0, every term inside this sum carries h. So every term, because of putting h tends to 0, would go to 0, and that means this whole term equals 0. With that implementation, I'm left with n x power n minus 1. This is a very important formula, and I want to rewrite this over here. That is, we learned that f prime, that is the derivative of x of n, which I write as d by dx to the power x n, is in fact equal to n x n minus 1. This is a very powerful formula for finding the derivative of functions or polynomial functions. For example, if n is equal to 2, then we would have a function like f of x equals x squared. According to this formula, the derivative f prime of x would be equal to d by dx into x squared, and as per this one result, here instead of n I have 2 over here, so I'll write for that in 2, and then x n minus 1 to 2 minus 1, I'll write this as 2 minus 1, which makes this 2x. So the derivative of x squared is then equal to 2x. Similarly, instead of square, if I have a cube over here, then I would have a situation like this, and then I would have this, and over here, then I have x cubed. So using this formula, I would have 3, and then 3 minus 1, so it would make it 3 times x squared. You can apply this formula to any power of x. For example, instead of a whole number as the power of x, supposedly we have a function like this where the power is half. Then I would have things like this. F prime of x would be equal to d by dx x power half. And using this form of the formula, I would write here n equals half and x power half minus 1. From this I get half, and half minus 1 is in fact equal to minus half. So I can leave it the way it is, or I can write this as 1 by 2 into 1 over square root x. 1 over square root x. Similarly, whatever the power of the function may be, if it is a negative power, like I have a minus over here, then I would have minus over here, a minus over here, and a minus over multiplied over here. So I would have a minus over here, and minus half and minus half is in fact 3 divided by 2. So I would have thing like this, s stands for minus 3 divided by 2. So whatever the power may be, you can use the power formula to find the derivative of a function. At the end, I would suggest you to memorize this formula. This is a very powerful formula for finding the derivative of the power of the functions. At the end, if you haven't yet subscribed to Safi Mix, kindly support the channel by pressing the subscribe button, and also hit the like button on the video. Thanks for watching.